Previous video we talked about the nyquist plot, right? Plotting this curve, okay, using the table. Okay, although I haven't plot finished the other points. Okay, we typically you need to first plot the zero when frequency equals to zero, and then you plot when frequency equals to infinity, and after that when the frequency equals to 1, 2, and then maybe like 5, 10. Just plot a few open, a few spreaded data, and then you can actually view, because you already know, because I already explained how the graph look like already, right? So typically you know how will it behave. So therefore, let's come back to what this video was trying to show you. Okay, the purpose of this video is actually to find this point over here. So in order to find this point, how do you find? Okay, and why do I want to find this point? Okay, why do I want to find this point? Okay, if you remember, to find gain and phase margin, okay, to find gain and phase margin, what do? We have to first in terms of gain margin, okay, phase margin is okay, but in terms of gain margin, you have to first find the lambda, right? So in this case, this lambda is actually this point that lies on the real axis, right? So in other words, this is actually the lambda. So when I find this point, I can actually find the lambda, and then I can actually solve my gain margin and see whether am I stable or not. Okay, and then also to prove that I am stable or not. So this is generally the case. So the first approach that I can do is there is actually two approaches. Okay, I haven't said it. So the first approach is actually when you are talking about the angle. You can actually use angle minus 180 degrees. The second approach, okay, is actually to say that when imaginary is equals to 0. Okay, with either one of them, you can actually solve for this point over here. So I think for this video, I'll just do first method. I don't know, but so in order to do this, okay, this is actually explained over here, lah. Okay, if you if you want to revise, okay, at least you know that I'm following this thing. So this argument gj omega is equals to minus 180 degrees, which is what I have drawn here. Okay, the transfer function. Okay, and then thus is equals to this is the phase angle that I've derived earlier. Okay, as you can see, this is the phase angle, right? It's the total same thing that I've said earlier. Okay, just the omega is different. In this case, they put capital omega, but it's the same equation. Okay, so when you put this, when it's negative 180 degrees, you know that you have something. Okay, so what we're gonna do next is to use this phase angle equation and the position of where we are. Okay, if you remember, actually I deleted away the picture. Damn it, what the hell. So let's redraw. Okay, so imagine this is the root locus, right? And then this is the point that contacts to this this real axis, right? I mean, yeah, this point now. Okay, so this is actually negative 180 degrees. So with this and this equation, we can actually do out the following. So what you do is actually here bring, because you know that this is 180 degrees, right? So what I can do is you bring this thing in. So therefore, this will cancel, and therefore we left over this one, right, and this one. And then if I were to bring this minus 2 tangent over here, it will become positive, right? Negative 2 tangent. So therefore I have positive 2 tangent, and then a tangent over here. After which, what we're gonna do is actually to put them together. So how do I put them together? Okay, now here comes the tricky part. Okay, how do you change this thing into this form? If you take a look, dun dun, stun, right? I also don't know what the fuck. But yeah, so actually it is just using tangent A plus. Hold on. So fear not, I am here to help you. What the hell? Okay. So 2 tangent minus 1 omega, right? I mean, it's actually tangent inverse omega plus tangent inverse omega, right? As you can see, this form is actually this form. Am I right? So therefore, after searching for quite a while, okay, I realized that this cannot be used. But still, yeah. So this is actually, so in fact, this is already the very simple trigonometry rule. Okay, so tangent inverse A plus tangent inverse B, okay, is equals to A plus B divided by 1 minus A times B, and then the whole thing tangent inverse. This is the trigonometry rule. Okay, this is the trigonometry rule. So let me define the trigonometry rule in this video. Okay, so tangent inverse A plus tangent inverse B, inverse B is equals to A plus B 1 minus AB. Okay, this is for if you have two terms, right? If you have like tangent inverse A plus tangent inverse B plus tangent inverse C, okay, what you're gonna do is totally a different thing. So it will be like A plus B plus C, okay, and then minus away A B C divided by 1 minus AB, and then minus AC minus BC. Okay, so these are the two rules you need to really memorize. Okay, I would recommend that you memorize it. Okay, so if you want to ask me how can I find this in the internet, I cannot find. Okay, this is like a closed door event. Okay, you cannot find this thing anywhere else. And this is very sad lah. So I searched quite a long time and then I found out this thing. Okay, this one can be used if you watch this video, right? Polar block for 3 simple poles and it's like 2 simple poles. If you go to Tech Guru Kula, okay, you can actually have that examples being shown quite and then yeah, it's over here. So and then this A, okay, this A and this B contains, let's say you have some 2 omega or maybe 3 omega whatsoever. Okay, so this A contains the coefficient, let's say 2 or 3, and omega itself. So it contains all the information in there. So I hope that I can make this very clear. So for this case, we are tangent inverse omega plus omega. So we can use this one because it's 2 terms. If it's 3 terms, you can use this. Typically, I don't think we'll go to four terms. If it's 4 terms, then good job lah. Yeah, that's it lah. But typically, we are only dealing with 2 terms and 3 terms as well. Okay. So with this very important concept, okay, maybe I should hold on a while. So I just copied it, and then let's erase this in order to save space. Okay. So let us come back here. Okay, since we know that this portion over here, this is tangent inverse omega, okay, plus tangent inverse omega. Simply we are talking about therefore this will be tangent inverse hold on, I go on now. Okay, before I go on, sorry, okay, before I go on, this whole thing, okay, this whole thing should be bracket tangent inverse. Okay, so I have actually forgot to tell you. So this is the actual rule. If you want me to tell you where's the rule, I also don't know. So let's continue first. So in this case, then we will have omega plus omega divided by, what the hell, divided by 1 minus omega times omega. So this is why we have 2 omega 1 plus omega square. 1 minus omega square. Okay. So I've cleared the $1 million question. Damn, okay, damn. So after which, once you get this, things will be easy. Okay, since this tangent inverse and this tangent inverse is the same, we can actually cancel. Once you cancel, actually, this is 10 ohm, and this portion over here is brought over here, right? And then, now what I'm gonna do is to bring this 1 minus ohm square up here. So I'll have 10 ohm minus 10 ohm cube equals to 2 ohm. Right, so I bring this portion over here to here. So as you can see, it's the same thing. Okay, this is square lah. Okay, this is ohm. Hope you get what I mean. So this is 1 over ohm square. Right? So if I multiply inside, I get this portion over here, and 2 ohm stays here. And then I just rearrange. I bring this 2 ohm in. Okay, so 10 ohm minus 2 ohm is equals to 10 ohm cube. Right? So this is where it shows I have 8 ohm equals to 10 ohm cube now. Okay? And therefore, with this, you can actually cancel. So I have 8 equals to 10 ohm square. Right? And therefore, if I were to bring this 8 over this 10 down, ohm square, and then if I were to square root, I'll have 4 over 5 square root. Okay. So in another case, if you want to further simplify, okay, I can actually factorize out the 2. So I actually have 2 over square root 5. Okay, it's just the same now, because if you were to bring this in into the system, okay, if you were to bring the square root in, it will be 2 square 5 already ma. Because yeah, okay, I just don't want to make things confused. I think you'll just stop here can already lah. This is really simple enough. So yeah, so this is the first method. Okay, I've talked so much. Okay, so this is the first method to find. Okay, using the negative 180 degrees rule. The second method I'll just show you in the next video. Okay, since I'm a little shack. It will be talking about the imaginary one. So we assume that not assume, but rather we know that this is actually imaginary equals to 0. So at this point, imaginary is equals to 0. So how do we use this phenomenon to solve it? So next video we'll talk about it. See you.